the notes for lesson 4.5, solving systems using inverse matrices. So if you recall in chapter 3, we talked about methods of solving systems of equations. We talked about graphing to solve, substitution, and elimination. This is going to be a fourth method that we can use to solve systems, and that is using matrices. So a system of equations can be written as a matrix equation. So our first example, we're going to write a matrix equation for the system below. Now the first part of our matrix equation is going to be our coefficient matrix, which we talked about before. So we're going to take the coefficients of our x's, and that's going to make our first column. So -3 and 2 make up our first column. Second column is the coefficients of the y's, so we have 4 and -1, and that is our first matrix. We're going to multiply that times our variables, so we have x and y, and that's going to be equal to our constant, so 5 and -10. So this is our matrix equation. So again, it's set up with our coefficient matrix, our variables, and then it equals our constants. So to find the solution of a linear system, we're going to let a times x equal b represent a system of linear equations. If the determinant a is non-zero, then the linear system has one solution, which is x equals the inverse of a times b. And we talked about that in the last section. So we're going to solve the system or matrix equation from above using inverse matrices like we did before. So the first thing we need to do is find the inverse of matrix A. You remember matrix A is our coefficient matrix from above, which is -3, 4, 2, -1. So we first need to find the determinant. So we're going to multiply -3 times -1 minus 2 times 4. So we have a +3 minus 8, which is -5. So remember that is our denominator. So to find the inverse of A, we are going to put everything over -5. So -3 over -5, 4 over -5, 2 over -5, and -1 over -5. So now let's simplify this. Remember, we have to switch the positions of A and D. So -1 over -5 becomes a +1/5, and that is our top left corner. Bottom right is -3 over -5, which is actually a +3/5. And for our other two positions, we are going to change the sign. Now since 4/5 is negative and 2/5 are negative, remember we take the opposite of them so they become positive. So we have a +4/5 and a +2/5, and again this is the inverse of A. So then to solve the system or the matrix equation, we need to multiply by the inverse. So we're going to take our inverse matrix, and remember we multiply it on the left on both sides. So 1/5, 4/5, 2/5, and 3/5. We're going to multiply that times 5 and -10. Now we have a 2 by 2 matrix and a 2 by 1 matrix, so we know that our solution is going to be a 2 by 1. So this is going to be equal to 1/5 times 5 is 1. 4/5 times -10 will be -40ths over 5, or -40 divided by 5, which is -8. Then we have our bottom row times our column. So 2/5 times 5, which would be 10 over 5, which is 2. Plus 3/5 times -10, which is -30 over 5, which is -6. So if we simplify this, we get -7 and -4. So these are x and y values. So our solution is -7, -4. Now again, we could have used graphing, substitution, or elimination to solve. All of them could work, but we can also use matrices as well. The next section we're looking at solving systems of equations with matrices and a graphing calculator. So we can also use a calculator to solve using the directions that we talked about in the previous section. So for part 1, or number 1, we need to write the matrix equation. So we're going to write a matrix equation for the system below. So again, we want our x coefficients in our first column. So if there's nothing in front of our x, remember that's a 1. So this is 1 and -3. And then our y coefficients are 7 and 2. Our second matrix is our variables, so x and y, and that equals our constants, so 5 and 8. So we just set up the equation. Now step 2, we're entering matrix A and B into your calculator. Again, you're going to use your 4.4 calculator directions if you need them. So this is going to be your A matrix and your B matrix. Notice they come from above. So this is A and this is B. So to solve the matrix equation in the system, you're going to use your matrix equation. So A times x equals B. So we need to multiply by the inverse of matrix A. So x equals the inverse of A times B, and your calculator can do the multiplication for you. So remember that you must multiply in this order or it will not work, because remember, multiplication of matrices is not commutative. So you're going to plug it into your calculator. If you have a Casio calculator, in your calculator it's going to look like this: matrix inverse A times matrix B. If you have a TI in your calculator, it is going to look like matrix A inverse times matrix B. So again, depending on which calculator you have, it's going to look a little bit differently, but you should end up with the same answer. So if you plug that into your calculator, you should get an answer of -2, 1. And again, we'll go over any questions that you have with the calculator in class tomorrow, but you should have gotten -2, 1. Example 4, we're going to use a matrix equation to solve the system below. Now notice we now have 3 variables, we have 3 equations, but we're going to write the equation the same way. So we're going to start with our x coefficients, so 4, 2, and -2. Y's come next, so -2, -1, and 3, and then z's, so 1, 3, and -2. Second matrix is our variables, so again, now we have x, y, and z, and it's equal to our constant, so 3, -6, and 1. So again, we're going to solve the matrix equation using your graphing calculator. So again, remember our first matrix here is A, and our last matrix here is B. So to solve the system using your graphing calculator, again, x is going to equal the inverse of A times B. So I want you to take a minute, plug this into your calculator, find the inverse, multiply that by B, and see what your final answer is. So when you plug this in your calculator, you should get 1 for x, -1 for y, and -3 for z. Our final example, again, we're using a matrix equation to solve the system below. Now notice our system of equations needs to be in standard form. So our first equation right now is not, it is in slope-intercept form. So we first need to change it into standard form before we can set up our matrix equation. So we're going to add 2x to both sides. So that gives us 2x plus y equals 5. And then we still have 4x plus 2y equals 6. So then we can set up our matrix equation. So it's very important that our equations are in standard form before we set up our matrix equation. So again, x's are in the first column, so we have 2 and 4. Y's are in the second column, so we have 1 and 2. Again, we have x and y are our variables, and it equals our constants for 5 and 6. So again, in your calculator, you're plugging in A and B for your matrices. To find the solution, or to solve, we're going to do the inverse of A times B. Again, it has to be in that order. So again, I want you to plug these into your calculator and see what you can come up with. Now you should notice that there is no solution to this system of equations. Now, when you are finding the inverse of A, you will notice that there is no inverse. And since there is no inverse, that is why there are no solutions. So if we have an inverse, we can find a solution. If there's no inverse, that means that there's no solution to the system of equations.